go. All right, I hope everybody enjoyed their pizza. We've got cupcakes on their way now, so after Chris's talk, we'll be able to grab some of those. And yeah, so let's learn about TensorFlow now.
Hey, I'm Chris Ollenburg. Can you guys hear me okay?
Yeah. A little louder.
A little louder. Is that better?
Yes.
Okay, cool. So I work at Skookum. I'm an Android and an iOS developer there. And I've been studying machine learning in my downtime. And it was kind of cool to see the keynote, like the end, on TensorFlow. So in some ways that might have stole some of my thunder here, but it's really cool that Google open sourced the same technology that they're using to drive a lot of their most innovative solutions. So my goals for this presentation are to get you excited about machine learning and then give you a high-level overview of TensorFlow. Also, I kind of hope to impart some of the technical jargon that you're going to hear if you start learning about TensorFlow. So what got me interested originally in TensorFlow was my side project. I have a street art app in the iOS App Store, and we're working on the Android version right now. But the first thing a lot of people do is they go and they upload a picture of something that is not street art. And I would like a way to automatically prevent that from happening. So image recognition is getting pretty good. And with TensorFlow, I could actually implement this now. So I've been trying to learn how to do that. Okay, so raise your hand if you've seen this image before. Okay, oh wow, cool. Well, don't tell anyone, we're gonna come back to it. All right, so what is machine learning? Well, what does it make you think about? You might think about AlphaGo or maybe Watson beating everyone in Jeopardy. I like to think of Arthur Samuel's definition, and this is from 1959. It's machine learning is a field of study that provides computers the ability to solve problems without explicitly being programmed. So I think that's kind of interesting that we don't call that AI because it can learn. And there's something called the AI effect, which is essentially once we understand how something works, we start calling it something besides AI or artificial intelligence. Although I think recently you've been hearing a lot more of the term AI for Google. Kind of half of the keynote was about different AI type technologies. And the way that I kind of like to try to think about the differentiation is that general intelligence is sort of what AI would be. Like it would be a human level intelligence, but machine learning often has more of a specific application. Like it can't really do much more than what you made it do. It doesn't really learn to do new things. So why should you care about machine learning? Well, I mean, it's pretty obvious that Google is building killer robots, and we should probably figure out how to stop them. So, yeah, maybe we should learn this and figure that out. But in reality, all industries are showing advanced machine learning applications. So Gartner has some kind of interesting statistics about that. They're predicting that by 2018, 3 million people will be supervised by a robo-boss. By 2020, Microsoft's central strategy is going to be around Cortana and not Windows. And that by 2020, machine learning will be a $30 billion per year business. So that's a lot of money and a pretty big opportunity. So when thinking about machine learning, I think it's important to kind of think about it from two different standpoints. One is kind of from a business standpoint, right? You just need to understand what's possible. That way you can maybe improve your business and not miss out. Also, you might think of an application that a technical person might not figure out. And then for technical people, it's going to be a really important skill. I mean, literally, at least half of the things in the keynote were built on something that involved machine learning, whether it was voice or image recognition. So there's a huge growing demand for this. People are going to start expecting to see this more often. And the major players in this space, Google with open sourcing TensorFlow, Microsoft has their own platform, Facebook just released their version of a TensorFlow. I think they called it FBFlow. And IBM has a framework. So it's really moving out of the academic domain to more of the practical domain, where you might not need to understand all about it to start implementing this technology. So when should you start learning about it? The answer is right now. And you've been using it, and now you probably do realize that you use it all the time, but you might not have. So some examples of when you would use machine learning are every time you Google something. If you use Netflix or Amazon, they use recommendation engines that are built on machine learning. Facebook's timeline uses machine learning to figure out what to show you. The United States Postal Service actually scans your envelope with a machine learning algorithm to get the addresses off of it. And then Google now is the obvious one, and their future, what was it called? Google Assistant. Then you've got Siri, Cortana, and Alexa. Those are using natural language processing. And I just saw this on Jalopnik, which is a car website, but a bunch of Googlers left to go help build these self-driving trucks. They don't tell cars how to drive. They teach them with a machine learning algorithm. So machine learning is a really disruptive technology, and there's 8 million workers in the trucking business to date. So when there's self-driving trucks that are going to be going all night and being very efficient at making convoys to save fuel, there's going to be a lot of human jobs that are displaced. So this is a really big deal, this technology. All right, so a little bit about the required knowledge that you kind of need to know to start getting into machine learning. It's a multidisciplinary field. So you need to know a little bit about basic programming, and I would recommend Python because that's what most of the machine learning and kind of more academic frameworks are built on. Then you need to know about data structures, so just like basic computer science stuff. Then basic linear algebra and calculus and statistics. So I mean, it's a lot of stuff to learn about. Yeah, I really thought about this though when I was learning about TensorFlow and thinking, I really should have paid attention in that calculus class in college, because you always thought that you were never going to use it, but now it's really important. Okay, so within machine learning, there's kind of some general problem types. You've got unsupervised learning, and that is more around something that you don't have a defined set of right answers. You just kind of are giving an algorithm something to look at and identify patterns. I've heard that Google News is a clustering algorithm, which is unsupervised learning. And then you have supervised learning. So that's kind of where you have a set of known right answers. And within that, there's two main types of supervised learning. So you've got regression problems. So a regression would be, say you want to predict a value, like a home price. And then a classification problem would be you have a discrete number of outputs. So say that you were trying to figure out if cancer would be malignant or benign. You might write an algorithm for that, and that would be classification. So I think it's also important to note that unsupervised learning is like 5% of the machine learning market right now. So it's kind of not as useful or pragmatic right now. That might change. Okay, so TensorFlow. I guess we heard a lot about that at the end of the keynote. It's the most starred repo on GitHub for machine learning. It's got a lot of really cool stuff in there. It lets you kind of take expensive operations that you would not want to run in Python and run them on something like a GPU. Okay, so there's three basic parts to TensorFlow, really. You've got TensorFlow serving. So Google built this TensorFlow serving framework so that you can deploy your trained models to a production environment, to an actual set of servers. So, if I actually implement the street art recognition algorithm, then I can use TensorFlow to serve that to my app. Then there is Tensor Board. That is how you kind of debug your models. So within machine learning, it's really all about a lot of data and choosing variables. So you don't debug that the traditional way that you would a normal program. You just look at the data and graphs of data to try and figure out why something's not working correctly. And Tensor Board is there to provide that for you. And then you have the central piece, TensorFlow, which is the library itself. And right now it's in Python and C++. You can run it on Android right now. And they were working on getting it to run on iOS as well. So that's pretty cool. This is kind of the general model of TensorFlow. That R should not be wrapped like that. I don't know. It's just that should say tensor. So you have a graph essentially when you start a TensorFlow program that you're building, and you want to feed tensors through the graph. So a tensor is just a multi-dimensional array of data. Then they call that a feed. So your feeds are your input tensors to your graph in TensorFlow. Each node in your graph is called an operation. So the operations are things like matrix multiplication, subtraction, general things like that. Then each op or node has kind of three different things. And this is a little bit specific to TensorFlow, but you've got the placeholder. So that's like saying you want to define your function inputs from your tensor. You create a placeholder in TensorFlow. Then you have a constant. That's pretty much the same concept as anywhere else. It never changes. And variables. So variables could change through the lifetime of your graph. The output of your graph, TensorFlow calls those fetches. So it has to be an output tensor. So the only thing that can flow through the graph is a tensor. All right, so for an example problem, if say that we had home prices for, like the perfect town in USA, and we could plot them from price and square footage. And so I'm a real estate agent, and then I want to figure out how to predict what a home price is going to be so that I know how to sell it. And it's not like a revolutionary problem, but it does kind of illustrate how you would go about building more complex problems. So you would probably start off by defining some function to input the square footage of a house and give your price. So that's what our function would look like. And that kind of looks like slope-intercept form, if you guys remember from math. So it is. So I'm going to gloss over some technical details about why you would use a cost function. But when I showed you the graph, you had a red line drawn through it, and you could just do that, line of best fit, or correlate the data in math maybe. But how would you tell a computer to do that? Well, it can't just look at the data and kind of guess like you could as a human and eyeball it. So there's something kind of from statistics called a cost or loss function, and you want to minimize that, and that gives you the best line. So imagine that you graph the data of the cost function, and this is what it would look like. So you got to solve for two different variables there, theta 0 and theta 1. You can look at this graph and say, I can see the minimum point. That's pretty easy for me to find. Now, for a computer, you need some kind of algorithm, and that's called gradient descent. So gradient descent is kind of you would say, imagine that you're on top of a mountain and you step on top, you look around and you find the next lowest point. So you take a step there. And then you do that again until you reach the bottom of the valley. So that's what gradient descent does, but for the cost function. Now, the mathematical algorithm over there is kind of complicated and might be sort of complex to implement in code. But with TensorFlow, it's one line of code. So that's cool. And
Now you're speaking my language.
yeah. So they've also got many other optimizers built into TensorFlow. So gradient descent is actually like not the most performant or best algorithm, but it's probably the introduction to it. So kind of, you would have a different equation, but you could still have a cost function. You would do the same type of thing to solve handwritten digits and recognize them. So if you go to the TensorFlow website, they call this the Hello World program to recognize human written digits. I think that's, I mean, it's a little bit more complicated than Hello World. But yeah, so in TensorFlow, it's only 19 lines of code. So I think that's pretty cool that you can write a program that can read the digits that you're writing in 19 lines of code. So if you tried to do that by hand, maybe thousands of lines of code with who knows how many edge cases. Also, I'd just like to say that some of the best algorithms for this today are, I think 99-point-something% accurate at predicting digits, which is actually better than a human can read digits. So that's, machine learning is pretty cool. Okay, so back to the image that I showed at the beginning. This is hallucinogenic drugs are seeing. And I don't recommend you try that to find out, but I think what's cool is that it really shows a correlation between how the human visual cortex is actually working. So you can kind of see that we're really getting closer to maybe a whole brain style emulation for AI. If you've read Nick Bostrom's book on superintelligence, he talks about this. But it seems like we're getting pretty close to AI, which is pretty cool. All right, that was my talk. And these first 3 slides are kind of what I did to get up and running in machine learning. Then there's some pretty good stuff down here in further learning and just my contact info at the bottom there. Does anyone have any questions? Cool. Yeah, I'll post it up in Slack. All right, thanks guys.